We're solving problem 16 from the 2024 AMC 12B. A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as 3 to the power of r times m, where r and m are positive integers and m is not divisible by 3. What is r? So we want the answer to be ideally written as 3 to the power of r times m, and we want to find r. So 16 people into 4 indistinguishable 4-person committees. So we have 16 people, choose 4 people for the first 4 ways. And then this would be 12 people now because 4 people from the first committee has been taken away from the total amount, chosen into the next one. Then 8 choose 4 people to go into 1 committee, and then 4 choose 4 people to go into this is the last 4 people, so it's just 1. Since all the committees are indistinguishable, we have to divide the total product of these by 4 factorial to get the number of ways to do this. And then, so we have 1 over 4 factorial times 16 choose 4 times 12 choose 4 times 8 choose 4 times 4 choose 4. This is going to get us 16 factorial over 4 factorial to the power of 5. So this is how many ways you can put them into 4 indistinguishable 4-person committees. Now, you want to, each committee will have 1 chairperson and 1 secretary. So the number of ways to choose the chairperson and secretary, if it's completely random, is you have 4 people in a committee. You choose 1 out of the 4, and then that's for, say, chairperson, and then the other one to choose secretary. There's now 3 people left to be either chairperson or in this case, secretary, because 1 person's already gonna be the chairperson, so there's now 3 people to choose to be the secretary. So 4 times 3 is 12 ways you can choose the chairperson and secretary for 1 committee. So we would then have 12 to the power of ways to choose the secretary and the chairperson for all 4 of the committees. So then the total number of ways to make the assignments would be this times that, 16 factorial times 4 factorial to the power of 5 times 12 to the power of 4. So, well, this might be hard to count, but this gives us essentially our answer in this form. So we just need to count how much powers of 3 there are. So for the numerators, 16 factorial and 12 to the power of 4, we add those, but we subtract the number of multiples of 3 in the denominator, because when you divide powers, they get subtracted off each other. So 16 factorial has 6 powers of 3. 4 factorial to the power of 5 has 5, and 12 to the power of 4 has 4. So since 14 factorial to the power of 5 is on the denominator, we subtract that, so we do 6 minus 5 plus 4, and this is going to give us our answer of 5, and we are done.